Hi, welcome to my video on sigma notation for a series. Sigma notation, a special notation used to represent a series. This symbol, which I have outlined right here, is a sum of. That's the sigma notation. K equals 1 is the initial term or initial number in a sequence. N is the number of terms that's in a sequence. And then we have the expression in terms of K. Instead of an N, we normally have a K. The reason we don't use an N because it gets confused with the N that's in this expression and the N that's here. They're not the same. Let's do some examples. Find the sum of each. So this is a sigma notation. It starts with K is 1 and it goes to 3. So K is 1, we go 4 bracket 1. So that's plus, we have a 4, and K is 2, and we have K is 3. So it's like subbing in values of N and Tn, or X and Y. We're subbing in X, working out. So this is 1, 2, 3. It starts at 1 and ends at 3. So it's 1, 2, 3 is the values of K. So we work each of these out. We get a 4. Work this one out. We get an 8. And I only have these square brackets in there to indicate that I'm doing it in each one of these separately. And then I get 4 plus 8 is 12 plus 12. So this is the sigma notation to represent this expression. Again, if you put 1 in, you get a 4. You put a 2 in, you get an 8. You put a 3 in, you get a 12. And the sum is 24. So we have another one here. Find the sum of this. And so this one starts at 1 and ends at 2. And it's 3K plus 1. So it's a 3. K is 1. So we work it out with 1 first, add on, and then we got a K is 2. So we work it out with a 2. So you're doing the expression twice. So that gives me, if you see, 3 times 1 is 3 plus 1 is 4. And this one, 3 times 2 is 6 plus 1 is 7. And the sum of representing this sigma notation is 11. And practice means pause your video and work out each of these. So here we go. Let's do this one. So it starts at 1 and it goes to 4 and K squared. So let's do, when K is 1, so we get 1 being squared. When K is 2, so we get 2 being squared. And when K is 3, it gets 3 squared. And when K is 4, it's 4 squared. Now I don't have to put the brackets around this. So 1 squared is 1, so that gives me a 1. 2 squared is 4. Now I could leave the square brackets there, but I'm working out each of these individually. I don't have to leave these square brackets in. I'm only putting them in to indicate that I'm doing it. Notice 1, 2, 3. So I could leave these square brackets off and get 4, 8, and 12. Same down here. That's a 9, and that's a 16. So notice I did when K was 1, K was 2, K was 3, K was 4, and I add it up, and I get a 9, 14, and I get a 30. 30 is the sum representing this sigma notation. And number 2, again we have K is 1, 2, and 3. Starts at 1 and goes to 3. So let's do, I'm going to use a square bracket just to, so we won't get it mixed up with the smaller brackets. So there's K is 1 going in, add on. Now I'm going to put K is 2, substitute it in. And now I'm going to substitute in K is 3. And I'll work each of these out. So we multiply before we add. Negative 2 plus 4 is 2. Add on. Negative 4 plus 4 is 0. And This is a -6 plus 4 is -2. Add it up, and I get a sum of 0. Let's continue with sigma notation. Write the series for each. So now we're going to write a series for each. Same thing, only we're going to when we get all the answers, instead of adding them all up, we're going to write a series. So when k is 1, we get 3 times 1. Notice I'm going to put square brackets. Let's did it once. Now I'm going to do k is 2. K is 3. K is 4. And K is 5. So there it is. We got 1, and so it's 1 to 5. 1, 2, 3, 4, 5. So that's a 3, and we want to write as a series. So that's a 6, a 9, a 12, and a 15. So write as a series means it's the sum of the numbers that's in the sequence. So there's the series that represents this summation. And we want to do this one. So we're going to use K is 1, 2, and 3, and we'll work it out for each of these. So let's start here. 4, 2, and K is 1. So we get 1 minus 1. So I sub that one in first. Add on. We got a 4 and a 2, and we're going to use K is 2. So I'm subbing them in first, and then I'm working them out after. So 4, 2, and K is 3. So there's K is 1, K is 2, K is 3. And now I'll work out each of these. So this is a 0. 2 to the 0 is 1, so that becomes a 4. 2 minus 1 is 1, so 2 to the 1 is 2, so that's an 8. And we have 3 minus 1 is 2, and we got a square first because of the PEMDAS. So we got a 4, 2 to the 2 is 4, and then we go 4 times 4 is 16. So there it is as a series. And I did some of these. Now you work these two out. Pause your video and see if you can write a sigma notation for these. That's reversing it. So to get a sigma notation means that you have to write it like this. So to get a sigma notation, we need, let's see, there's what we're doing. We're doing it like this. So the sigma notation, we start off at K is 1, and we don't know how many terms we have here. So let's work out 5 minus 3. So 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. So that means that the D1 difference is 2. And what I'm doing now is trying to find the equation that represents the sequence. And notice that it's a linear or it's an arithmetic. And for T1 is 3. So that means that Tn equals T1 plus n minus 1 times D. So T1 is 3. N minus 1 times 2. So that's 3 plus 2n minus 2. So that's 2n plus 1. So that's the expression. But instead of putting n in, I'll put 2k plus 1. And what is this term right here? Well, this 15th term, that's 1, 2, 3, 4, 5, 6, 7. So that's number 7. So that's k is 1 up to 7 for this expression. So if you take 1 and sub it in, you'll get a 3. Take k is 2, sub it in, you get 4 plus 1 is 5. If you take the last one, which is 7, and sub it in, 2 times 7 plus 1 is 15. So this is the sigma notation that represents, no, this is an arithmetic sequence. Okay, and let's see if we can do the sigma notation for this one. And it's either going to get a differential or we're going to get a ratio. And it looks like there's, let's see, R is 15 divided by 5, and that's a 3. Ratio, 45 divided by 15, and that's a 3. So we have a ratio of 3. And the first term is a 5. So that's a geometric sequence, which is a geometric series. We're all adding them up. So we have Tn is T1 R to the n minus 1. So Tn, T1 is 5, and its R is 3. So that's the formula that represents the sequence. So that's the, if you think about it, this is 5 and 2, 3, and it's a K. Instead of an N, it's a K, because K starts with the first term of 1. And what we got to do, we know that if we put a 1 in here, K starts at 1. 1 minus 1 is 0. 3 to the 0 is 1. 5 times 1 is 5. Now, but this is 1, 2, 3, 4, 5, 6. So if we think about it, then this is, we're multiplying by the 6 terms in the sequence. So this is the sigma notation that starts. This is the first term, second, third, fourth, fifth, sixth. So I worked out the expression that represents this geometric sequence, and then I started with 1, and I went with the 6 at the end to say there's 6 terms. Okay, just doing the sigma notation. And we have some more to do. Express each in sigma notation. So this is extra practice. So pause your video and work these out. Again, in order to work these out, we need an expression. So notice this is 2, 6, 10. Notice you see is going up by 4. 6 minus 2 is 4. So if you look at it and do it this way, you get a 4. They do that, you get a 4. So the D1 is a 4. Again, 14 minus 10 is 4. So, and we also have that the first term is 2. So we have to work out that Tn, it's an arithmetic sequence because it's got a level 1 difference. That's T1 plus n minus 1d. T1 is 2, and it's n minus 1. The difference is 4. So that's 2 plus 4n minus 4. And so Tn becomes 4n minus 2. So we have, in order to do the sigma notation, the sigma notation is like this. We start with k equals 1. The expression is 4n minus 2, but we'll use the 4k minus 2 because we start with a k here. So instead of an n, we have a k, but we have to find what number to put here. So if you could keep going on counting here and go up and say 18 and so on and count them, that's one way to do it till you get to here and count your numbers. So you could put an 8, add on 4, 18, and add on 4 is 22, and keep going like that, 26, and then 30 to get to 34. But if you had a large number here, a big number at the end, and you had, say, 100 times, that would take long to do. So another way to do it is take the 34. This is the Tn. So if we go Tn is equal to 4n minus 2, 34 equals 4n minus 2, negative 4n, negative 2 minus 34. I move the n over, and the constant to the other side, change the sign, so negative 4n is negative 36, divide by negative 4, and I get n is 9. So this 34th term here, that's the 9th term. So there's the 9 that goes up at the top. So you start with 1, and you're going to 9. So there's 9 terms, and there they all are. So this is the sigma notation that represents this series. And we have another one to do. Again, pause your video and work these out. Very similar again. We have this time, notice that's being doubled. So we have a ratio this time. So that's a 2. And ratio is 12 divided by 6 is a 2. So we have a ratio of 2. And we have the first term is a T1 is 3. So the equation is Tn equals T1 r to the n minus 1, because it's a geometric series, which we have this equation. So Tn is equal to T1 is 3, and we have a ratio of 2 to the n minus 1. Now, in order to do the sigma notation, which is this design, k starts at 1, and we have this equation, 3, 2, and instead of an n, it's a k, like that. But we have to find out what this 192 is. So the 192 is Tn, so that means that 3, 2 to the n minus 1 is equal to the 192. So we want to find what n is. So we divide by 3. So we get 2 to the n minus 1 equals 64. So this is 2 to the n. So 2 to the n minus 1. So we need, since this base is 2, I need a 2 here. And 64 is what? 64 is 8 times 8. And 8 is 2 cubed. This 8 is 2 cubed. So 64 is 2 to the 6th. Because both bases are the same, so that means n minus 1 equals 6. So n is 6 plus 1. N is equal to 7. So that's the 7th term in this sequence. So we put a 7 there. So this is the sigma notation that representing this series. And find the value of this sigma notation. Again, the expression is k squared minus 2k when k is 1 up to 3. So we have, let's do it once, k is 1, so we'll put a 1 in. So that's when k is 1, add on. Now we're going to put k is 2 in, 2 here. So we're putting 2 in this expression, and we have to do 1, 2, this is the third one. So we'll put 3 in for k. And so we put a 1 in, we put a 2 in, and we put a 3 in. So we have to work this out. So this is, if you work this one out, rather than, we have to square first, so that's a 1, and we multiply next is negative 2, so that gives us a negative 1. Add on. So we square first to get 4, and then we multiply after by PEMDAS, so 4 minus 4 is, that's a 4 minus 4, so that becomes a 0. And same thing, we have to do the square first, it's a 9. We multiply next to get 6, so that gives us a 3. So when we add that up, the value of this sigma notation with this expression, with the terms 1, 2, and 3 is a 2. So that ends this unit. There are 2 more videos going to be done to do the quiz or review of, there's at least 19 videos to do a review on it. I have to do it in 2 review videos. And if you like this video, click on the like button, subscribe button, visit my website www.mathfullyexplained.com to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.